right, so we're going to get some understanding of negative and zero exponents. We're in 2.4 RSG 14 and 15. So we've talked a lot about negative exponents, and one of the things that I've taught incorrectly, I will confess up to you all, is I've taught the procedure without giving students like real understanding. So now my students understand that negative exponents just means it's that many factors of 5. I mean, that many factors of 2. So 5 factors of 2. And instead of multiplying, we're actually dividing. Okay, we're dividing by factors. So if you think about like 3 squared means 3 times 3, right? So this negative exponent means I'm dividing by instead of multiplying by. Does that make sense? So here, if I wanted to rewrite 2 to the negative 5th, it looks like this. So instead of multiplying 2 times 2 times 2 times 2 times 2, right? Then I'm just putting that in the denominator and we're dividing by it. Okay, so that's what that actually means. So what were the directions? Rewrite the following expressions using exponent rules and relationships. So there is only one exponent in the expression and all exponents are positive. Rewrite your answer in exponential form. Okay, so they just wanted us to rewrite this using a positive exponent. Well, you can't just erase the negative, right? That doesn't work. That'd be really cool if you can erase the negative. That means I can go and spend, tons of money on my credit card, and that is considered a negative, right? That's a negative balance. So then I would just erase my negative and be like, boom, there you go. I'm not negative anymore. And that doesn't work. So how do I rewrite this? So I see 2 times 2 times 2 times 2 times 2. That means it's 2 to the 5th. Except for now, 2 to the 5th is, we're not multiplying, we're dividing. So that 2 to the 5th just stays on the denominator. So that's my answer. So again, the big thing that you're supposed to know about negative exponents is that those are factors of division and not like up here, factors of multiplication. Does that make sense? Okay, zero. The zero exponent, I'm going to start with the biggest mistake everybody says. And the biggest mistake everybody says about this one, is that negative exponents mean negative answers, and that's not true. And I can prove that in several different ways. The easiest way for me to prove it is by using the exponential graph. If you look at the exponential graph, it doesn't even dip into the negative side of the y-axis, right? So that's how I know, number one. Number two, all I'm doing is following a pattern, right? And the pattern that I'm referring to is looking at exponents. So I'm going to use that pattern to prove to you what 17 to the 0 is. There's many different ways, but I'll go with the pattern just so that you can all see it. So I'm going to say what 17 to the 1st is, and you're like, oh, that's easy. That's 17. Okay, good. And what's 17 squared? And you're like, oh, that's easy. That's 17 times 17. Which is, I don't really care at this point. I'm just going to be honest with you. I know that 17 times 17, I think is 289. Or is that 14? No, yeah. I think it's 17 times 17. But anyways, I don't care what it is. I'm just going to show you a pattern. And 17 cubed means 17 times 17 times 17, right? And if I keep going up, all that's happening is I'm just adding a factor of 17 and multiplying it by it every single time. So here I have 1 factor, exponent of 1, 2 factors, exponent of 2, 3 factors, exponent of 3. So if you look going up, as we travel up this way, we're just multiplying by 17, right? So as I travel up, I'm multiplying by 17, right? But if you want to think about it too, if I travel down, I'm just dividing by 17. And that's why it's important for you to understand like the inverse relationship between multiplication and division. So if I want to travel up, I'm going to multiply by 17. But if I want to travel down, like going to smaller exponents, I'm just going to divide. I'm going to divide by factors of 17, right? So divide by 17 here, divide by 17 here. And that's actually going to help me prove what 17 to the 0 is, and even negative exponents like this. So back to my pattern, what is 17 to the 0? Well, if I'm at 17, right, and I divide by 17, right? If I'm at 17 and I divide by 17, well, what's 17 divided by 17, right? So what's 17, make it small, divided by 17? Well, that's just 1, right? So there goes. There's my pretty simple, simplistic, it's not a proof, but it's a way for you to see why it's equal to 1. So there's my answer, it equals to 1. And if I continue this pattern, right? So here I'm going 3, 2, 1, 0. The number before, the integer before 0 would be 17 to the negative first. And so if you continue this pattern over here, we're just dividing again by a factor of 17. So what's 1 divided by 17? Well, it's just 1 divided by 17. And if I do it again, I get 1 over 17 squared and continue. So this is just a simple way for me to show you what 0 exponents equal to, anything to the 0 except for 0, and negative exponents mean. Common mistakes, 17 to the 0 is 0. No, that doesn't work. It doesn't work like that, right? We're not multiplying 17 times 0. We're saying 0 factors of 17, and it's 1. Thank you so much. Have a great day.